Hello and welcome to our first online class video. What I'm going to do here is I'm going to go over some of the questions like I would normally in class, show you how to work through them. Now I'm not going to go through every question. For example, if a question has A, B, C, and D, and those examples are just more practice, I'll show you how to do one, and then I'll post the answers online like I normally do. Now for this video, do make sure you try to do the questions as best as you can before you watch it, but if you get stuck, that's what this is here for. If you have any questions during this or anything at all, please don't hesitate to email me. We can set up a video conference if you want to talk one-on-one about how to do these or anything else. And don't forget that we will also have homework due every Sunday night, just like normal. Alright, let's get into it. So today we're talking all about acids and bases. And one more thing, I'm not going to go over like the example or the information like I do normally. I'm just going to get directly into the problems, because the reason I go over the information in class is that I want you to be reminded of what you watch in the video. Well, you're at home, you can watch the video over that stuff, so I'm not going to repeat myself twice when we already have that in video format. Alright, so what we're talking about are acids and bases, and we are talking about binary acids here, that is just a hydrogen with one other atom. And we want to know which acid is the strongest, where we can assume white atoms are hydrogen, purple are our other atom. Here A, it could be Cl, could be any other atom. Now what makes an acid strong is its ability to dissociate hydrogens. So the more hydrogens we have separated from our other atom, A in this case, the stronger our acid. So in beaker 1, all of the acid has been dissociated. Acid 2, roughly 50% has been dissociated. And acid 3, only one molecule has been dissociated, which means 1 is the strongest acid. We have the most hydrogens coming off. 2 is the next strongest because that has the second most. 3 is incredibly weak, is the weakest. We only had 1 hydrogen come off. So in order to decrease in strength, it would be 1, 2, and 3. Now next is problem 2, and let's get to it. I forgot to take off that previous slide. So I want to calculate the amount of OH in an aqueous solution at 25C and determine if that solution is acidic or basic if I start with a hydronium concentration of 1.2 times 10 to the minus 8. So hydronium H3O plus, that's our acid. Normally chemists will shorthand that as H plus. H plus doesn't actually exist, it's always going to be H3O plus. So when you see H3O plus, it means acid. Alright, so when we're starting with just an acid concentration or just a base concentration, we need to go to this equation. The amount of acid times the amount of base in water is actually a constant that changes with temperature. So at 25C, when you multiply the concentration of acid with the concentration of base, that value is always 1 times 10 to the minus 14th. So that's what we're starting with here. Acid times base concentration equals Kw, which equals 1.0 times 10 to the minus 14th. We're given hydronium concentration, so I plug that in, and I want to solve for OH, so I want OH alone, so I'm going to divide each side by the acid concentration, and you get the hydronium concentration is 8.33 times 10 to the minus 7. And now we have to figure out, is our solution acidic or basic? And what that question is really asking is, what has the greatest concentration, OH minus or H3O plus? So you're just comparing the two numbers. Now we have negative exponents here, and we're mainly going to be dealing with negative exponents. Not always, but mainly. So the smaller the negative exponent, the bigger the number. So something times 10 to the minus 7 is bigger than times 10 to the minus 8, which makes this basic. And D, for that problem, it's the same thing, but this time we're starting with hydronium, OH minus. That's called, or sorry, hydroxyl, not hydronium. Hydronium, H3O plus, hydroxyl is OH minus. So we do the same thing where we solve for H3O plus. We compare the two numbers, and we see this time our acid number is bigger than our OH number, which means this is acidic. Alright, so let's get to the idea of pH plus pOH. So I want to calculate the pH and pOH of a solution if my hydronium concentration is 1.7 times 10 to the minus 8. So what the P in pH and pOH means is minus log. So pH equals minus log H3O plus concentration. Well, I'm given the concentration, so in your calculator you would actually type minus sign log concentration. And when you do that, you should get 7.77. Now, to determine if something's acid or basic, you can use pH. If the pH is above 7, it's basic. So this is a basic solution. If the pH is below 7, it's acidic. And if pH is 7, it's neutral. Now to get pOH, we have this equation. In water, the pH plus the pOH always equals 14. So pH is 7.77 plus pOH equals 14. So I want to solve for pOH, so I subtract 7.77 from each side. pOH equals 6.23. Now you can determine acid and or acidic and basic from pOH. It's the opposite. So low numbers in pOH means basic, high means acidic, or rather below 7 and above 7. It can get confusing, so usually I just stick to pH. And if you have pOH, you can always solve for pH using this equation. So I would suggest just sticking to, is pH above 7, then basic. Is pH below 7, then acidic. Alright, and now we're going to strong acid. So a strong acid is an acid that will dissociate 100%. So if I have 0.25 molar HCl, that means I'll have 0.25 molar H3O plus. So anytime you see a strong acid, it's giving off the hydrogen 100%. So I want to determine H3O plus concentration. That's easy. If I have 0.25 molar HCl, that means my hydronium concentration is 0.25 molar as well. Once you have H3O plus, you can solve for pH, because pH, remember, the P means minus log. So it's minus log of H3O plus. If H3O plus is 0.25, pH is 0.602. So H3O plus and pH is easy to solve for. Now, to solve for OH and pOH, you have two different methods to do this. That's why I have these two arrows. So let's start with the left-hand side. So remember, we have the equation that H3O plus multiplied by OH minus equals Kw. Well, I can put in my H3O plus concentration and solve for OH minus like we did on our previous problem by dividing this by Kw. You find that OH is 4 times 10 to the minus 14th. That's your concentration of OH. Then you can solve for pOH by just doing the minus log of that. So minus log of this concentration is 13.4. Another way you can do it is that pH plus pOH equals 14. You got pH already, so you can solve for pOH, and that's 13.4. Now, from pOH, you can directly solve for the concentration of OH, because remember, pOH equals minus log of OH? Well, POH equals 13.4, so 13.4 equals minus log of OH minus. And then move the minus sign over, multiply each side by -1. Negative 13.4 equals the log of OH minus. Now to get rid of a log, you raise each side to the power of 10. So 10 raised to the power of minus 13.4 equals OH concentration. OH equals 4.10, or 4 times 10 to the minus 14. Just like we got in our previous way of solving this. Or you could combine this approach, right? So you could use H0 plus multiplied by OH minus equals KW. Use that to find OH concentration. Then you could use pH plus POH equals 14. Use that to solve for POH. Either way you want to do this, you will get the same answer. So just do whatever seems less complicated to you, whatever seems more comfortable for you, and you should have no problem solving these type of questions. Alright, so that's it for this video, and again, if you have any questions, do not hesitate to ask me. I will answer those through email, or we can set up a video conference. Otherwise, I will see you in the next video.